In our world, temperature is just one thing. If a freezer is cold enough to make ice, any water you put inside it should freeze. But quantum mechanics allows for objects to exist in uncertainty between multiple states, in a sense to be more than one thing at the same time, just like Schrodinger's cat is both alive and dead in his thought experiment. And quantum objects can, from a certain point of view, be both hot and cold at the same time. The realm of quantum physics is at times bizarre and confusing. It contains a number of principles that defy logic, like quantum tunneling, where a particle is able to penetrate ghost-like through a solid object. The new series is completely based on explaining quantum physics and thinking beyond the conventional laws of physics. This journey into the quantum realm will be led by Mr. Strange. Fasten your seatbelts and get ready to experience a roller coaster ride in quantum realm.
Motion. At first sight, it is something incredibly uninteresting and trivial. People have been studying motion for thousands of years, but it was not until 1687, when Isaac Newton formulated his 3 laws of motion, that people finally started to understand it more deeply. Newton's laws of motion were so ahead of their time that some scientists still consider Newton the most revolutionary physicist of all time. But even Newton's laws are not perfect. And in 1905 came the special theory of relativity, which brilliantly describes the motion of objects moving at high speeds, formulated by Albert Einstein. But there is another theory that started to develop at the same time. A theory that completely changed our perception of reality. In 1900, the cornerstone of quantum mechanics was laid. Quantum mechanics deals with objects from the so-called microworld, like particles or atoms. These objects behave nothing like objects of classical proportions from the so-called macroworld we ordinarily deal with, and thus cannot be described by classical physics. I'm Mr. Strange, and welcome to the realm of quantum physics. Quantum mechanics deals with objects and its physics at the atomic scale. This domain is governed by Heisenberg's uncertainty principle, which states that one cannot measure the position and the momentum of a particle simultaneously. When you perform an experiment to measure the momentum of the particle, you disturb the system and thus throw it in chaos as far as its position is concerned. Likewise, any attempt on measuring the exact position of the particle risks the system going into absolute madness with its momentum. In the real world, it is as if you are standing in the middle of the road and you see a car approaching towards you. Either you can look at the car and know its exact position at any instant, without knowing the speed with which it is coming towards you, or you can measure its speed, which will make the car look super fuzzy and highly blurred, thus making position measurement impossible. Another principle, which is the backbone of modern-day quantum computers, is the principle of superposition. It may sound strange, but in quantum world the particle is present at more than one place at any instant of time. Any active measurement tends to collapse the superposition into a single output, which is governed by the probability of finding the in that state. Again, to make things intuitive, there's a very tiny but non-zero probability of you being present here and at Paris right now. Of course, there are many more things to talk about regarding quantum physics, but the point is, can we really ask proper questions in this regime? Quantum physics poses a critical question on the role of observer. As discussed before, it is our active measurement which changes the outcome of an experiment. So does that mean we can never observe things at the quantum scale? Quantum theory has not only expanded the boundaries of human knowledge, it has also shown us our place in the universe. There's still plenty to discover. There is still a lot to wonder.
In the next episode, we will travel back in time to learn how quantum physics emerged and evolved. Hey, I am Miss Keen. Thank you for watching. Don't forget to like, comment, share and subscribe to my channel. And for latest update, hit the bell icon. Until then, keep exploring.